All right, so this video is going to be a video on review of transformations. Remember, those transformations are going to be rotations, reflections, and translations. Okay, so our first problem says the point -4, 3 is reflected across the line y equals -x. I'm just going to underline that because that's going to be an important thing. And then the resulting point is reflected over the line y equals 3. And then we need to find out where that new point is going to be. So the first thing I'm going to look at is my point. So it's at -4, 3. Or -4, -3. But then it needs to reflect across the line y equals -x. So if we recall, y equals -x, the rule, it goes from xy to -y, -x. So for that point, I'm going to go from -4, -3. And then my rule tells me I need to flip the x and y, and I need to take the opposite. So I need to go from -4, -3 to +3 and +4. So I'm going to go over my graph. I'm going to plot it. I'm going to go over to 3. I'm going to go up to 4. So this is my new point. But then I have to reflect it over the line y equals 3. So y equals 3 is here. It has to be equidistant, so it needs to come over. So this line is at 3. So I'm only 1 away. So if I reflect it over across, it's just going to be right underneath, only 1 away. So my new point will be 3, 2, which is right here. Okay. The next one is we need to describe a transformation from triangle 1 to triangle 2. So let's look at this. So these triangles look congruent, so it just looks like we are just sliding this triangle over. So I'm just going to kind of look at my triangle, and I want to see which points might look like they're in the same place. And I can see that this one and that one are in the same place of the triangle. So I need to figure out how this triangle moves down here. So I just need to figure out what we need to go, how much it moves. So I know I can see that it moves down a little bit and over to the right a little bit, but let's figure out how much we go down and how much we go right. So I'm going to just draw like a little triangle so I can count. So let's count how much does it go down. 1, 2, 3, 4. So it goes down 4 units, so translates down 4 units, and it moves to the right how much? So let's count again. 1, 2, 3, 4, 5. So it goes to the right 5 units. So our next one's pretty lengthy. It's multiple choice, so we can use our process of elimination on this one. So let's start with, suppose a point 2, 3 is rotated 90 degrees clockwise around the origin and then reflected across the line of y equals x, and then rotated 180 degrees counterclockwise back around the origin. What transformation would result in the same image? So how we're going to go about doing this problem is I'm going to look at each of my answer choices, and I'm going to use my rules that I know. So for 90 degrees counterclockwise, my rule is the point goes from xy to -y, so the opposite of y, comma, x. So I'm going to look back at my original point, and I have 2, 3. if it rotates, I need to flip my x and y. So my 3 will now come first, but then it tells me it's the opposite. So it's going to be -3, and then my x stays the same, but it's just in the y spot. So it's going to be -3, 2. Next one is going to be 180 degrees counterclockwise. So that's going to go from xy to the opposite of x, comma, the opposite of y. So the orientation stays the same, but we are just making them the opposite. So if it was at 2, 3, it is now going to be at -2, -3. Next one, a reflection over the line y equals -x. That goes from xy to -y, -x. So we are flipping the order and we are taking the opposite. So if it goes from 2, 3, the order needs to change. So 3, 2, but they are both opposite. So it's going to be -3 and -2. The last one, a reflection across the y-axis. We are just going to change the x. So it goes to the opposite of x, comma, y. So the orientation stays the same. It's just going to be the opposite of x. So if we have 2, 3, that's going to go to -2, comma, 3. All right, so now let's go back and look at our problem. So we start with 2, 3. We rotate 90 degrees, and then it's reflected across y equals x, and then rotated 180 degrees. So we have 3 different things. So let's think about this. So my 90 degrees is xy to -yx. And I need to do y equals x, so y equals x goes from xy to yx. And then lastly, my 280 or 270 degrees, no, it's 180. So 180 goes from xy to -x and -y. So now let's look at my point. So I'm going to start with 2, 3, and I'm just going to go in the order. So my first thing is I need to do it 90 degrees. So I need to take my 2, 3, and I need to do it 90 degrees, which is what we did in A. So it's going to be -3 and 2. So that's my 90 degrees. Then I need to look at what my rule is for y equals x. My rule says that I just need to flip the x and y. So if I flip my x and y, the 2 is going to come first, and then -3 is going to now be in the y spot. And then finally, I am going to look at this for y or 180 degrees. The order stays the same, but I need to take the opposite of my x and the opposite of my y. So it's going to be -2, comma, 3. So that is where my new point is going to be. So then I need to look at my answer choices. I get -3, that's not the same. -2, -3 is not the same. -3, -2 is not the same. But reflection across the y-axis, it will be the same because it's at -2, comma, 3 as well. Next one, triangle A, B, C, and D, E, F are graphed on the set of axes below. Which sequence of transformations could put the triangle ABC onto D, E, F? So if you look, our important thing says A, B, C, and D, E, F. So that means A goes with A, E goes with B, and C goes with F. So I need to figure out how this point A gets to point B. How point B could get to point E, and C get to F. So I know that it goes from this quadrant to this quadrant, and it looks like it's rotated a little bit. So I'm just going to use the coordinates of point A. So let's look at point A. So it would be -5, 2. And then D is at 2, -5. All right, so I can already see a relationship. They both have a -5, but the -5 is in the x at A, but it's in the y of D. It doesn't change, so I already know that if it doesn't change and they flip, that is going to be a 90-degree rotation. So if you rotate 90 degrees clockwise, counterclockwise, so CW, so counterclockwise, let's take A. So A is at -5, 2. If you rotate 90 degrees, it goes to -2 and -5. So I'm going to plot that. So -2 and -5 is right there. But I need to get here. So then I can notice that this point is 2 away from the y. This point is also 2 away from the y. So maybe if I reflect over the y, that will work. So let's do reflect over the y-axis. Let's test it. So it was at -2, -5. If I reflect over the y, I only change the x. I need to take the opposite of -2, which is +2. And it needs to be at -5, which is what we want. So my transformations are going to be rotate 90 degrees counterclockwise around the origin. Then reflect over the y-axis. All right, last one. It says, prove that these triangles ABC and DEF are congruent given the vertices ABC and then DEF. So if they are congruent, then A goes with D, B will go with E, C will go with F. So let's just pick, I'm just going to pick A and D. I'm going to follow my rules. So it says, for A, it says the triangles are congruent because ABC mapped onto DEF by a rotation. So let's look at point A. So A is at 1, 4. Then I need to do the rotation -y, x. So I need to flip them into the opposite of my y. So -4 and 1. Then it says a translation of xy to x, y minus 5. So my x stays the same, so -4. But then it says y minus 5. So 1 minus 5 is -4. And that is not what D equals, so that's not going to work. Okay? Now, let's look at B. So I'm going to start my point again. At point A, says 1, 4. Then I need to do the translation of x minus 6. So I'm going to look at 1. I'm going to take away 6. That's going to be -5. Then it says y. So my y stays the same. Then we have another translation where x stays the same. Then it says y minus 4. So 4 minus 4 is 0, which is not -1, -2. So nope. Okay, let's look at C. C says can be mapped onto DF by a reflection. So let's start with A again. So 1, 4. And then it says reflection -x, y. So opposite of x, so -1, 4, because the y stays the same.